Hello, everyone. We'll wait 1 or 2 minutes to let people join, and we'll start. Okay, so this is not our first attempt to make a blockchain course. Definitely, I've been doing this for like 7 years already, but it's our first attempt to do it in English. And it's a little bit challenging, so like my English is not like super proficient, but I'll do my best. If you have any comments regarding suggestions, please pin me in some messenger and I'll improve myself. So my goal, I am Pavel Kravchenko, as you know, I'm the co-founder and CEO of Distributed Lab. My goal was always about educating people regarding this new industry that is like super exciting, super sometimes hard, but definitely, yeah, revolutionary. So we'll do a lot of such recordings. Each one will take approximately like half an hour. We won't make it super long. We do also streaming to Clubhouse. So if you're there, you can join, you can find me by looking, yeah, Pavel Kravchenko. And the first, so to say, lecture will happen here about Bitcoin. And it will be not super technical because we'll see the conceptual parts. All these recordings will be available on YouTube. So if you're missing something, don't worry. And our end goal will be that we'll be making some kind of encyclopedia. So we already have 5 books published. They're available on Amazon, but we want to kind of formalize all this knowledge and describe it in such a way so it could be compared. So we have like a rough plan for each topic. I already posted this plan on like YouTube and on LinkedIn and Facebook. So we will be reviewing for each topic. We'll be touching. We'll be reviewing some definitions. We'll be reviewing the history of a particular technology. We'll be reviewing the context in which we view the technology, some problems that it solves, principles, architecture, life cycle of the objects, if applicable, technical details, security aspects, strong sides, features, how we can use it, limitations, like the best and the worst application industry, then some drawbacks, some comparison with competitors, and tendencies in the future. So this is our goal, to make it more like structured. Obviously, like the industry is super new, and some concepts are still not clearly defined, and there are a lot of ambiguity about like what is this, what is that. So for example, there is no consensus, so to say, in the industry regarding what blockchain is and what it does and why it's needed. And it's not because people like don't know their stuff, but it just they think about technology, about aspects from different perspectives. And they see like an elephant, they look at, they touch the elephant in different, yeah, limbs, so to say. So we will be biased, but we'll try to kind of provide like proofs to our knowledge and let you decide what's the best, what's not. I will be starting with these lectures, and then my colleagues and other speakers will join me, doing sometimes deeper technical lectures or some specific topics. So this is like an overall thing. It won't have a clear end. So we plan to record approximately like 300 lectures. It will definitely take a lot of time, but the industry, as I feel, will be evolving really fast, even like in a few years. So definitely not all innovation will not stop tomorrow. Okay, so now we start and talk about Bitcoin. So first of all, some definition, what Bitcoin is. You can treat it from different perspective, but from one side is an accounting system that contains identifiers and balances. And balances are indeed in this virtual currency, Bitcoin. You can think about it as a digital commodity. You can think about it about like a game currency. Basically, it has no physical counterpart. It just people said, "Oh, now we have these Bitcoins and let's exchange them." And from the other side, it's a protocol that implements the payment system and the processing engine for the transactions. So it's like a completely new digital currency. Bitcoin is considered a cryptocurrency, which means quite a lot of things and implications. People had already, so we come into history, people already tried to invent digital currencies and they succeeded, and we saw many. So to some extent, PayPal is also digital currency, and web money, also digital currency. But cryptocurrency is something new. And what's new is that now you don't have the most important thing is that you don't have a company or person that runs the whole system. So people all together run the system collectively. They do all the things that should be implemented in a normal accounting system. They do the issuance, they do the transaction processing, they do the transaction like the data storage, they do the audit, they do the communication between themselves, and actually governance. So they govern the system altogether according to certain rules. So this system is truly decentralized, and until Bitcoin, there were no financial systems that possessed these properties. There were systems in other industries that were truly decentralized, like mesh networks or some data storage or data transmission, like torrents. But for financial system, it was completely a revolution. And this was something that we will talk about some important features of Bitcoin and principles a little bit later. Some short history, people made attempts already to create something like Bitcoin, like David Chaum was very active in that. He created DigiCash, Adam Beck, Hashcash, Nick Szabo, like BitGold. And these people, some of them are still active in the blockchain space, like more than 20 years ago. More than 20 years they're doing this. But Bitcoin itself was suggested by an anonymous person, Satoshi Nakamoto, in a white paper on the 31st of October and 2008. And then Bitcoin network launched in the 3rd of January 2009. So it's already like 12 years. So it's not too much, but not too little. Not the same. And the context in which we should treat Bitcoin could be different. Again, depending on from the perspective from which you're looking. If you look from the financial perspective, it is just like it's like digital commodity. we have some registry and records, and that's it. People kind of, they own the, like, they control the ownership right about some digital commodity. From the other side, you can think about this as a payment system. As soon as people can transfer to each other these digital coins, it becomes a payment system. And if they use it a lot in a certain ecosystem, it becomes a currency. So effectively, we can think Bitcoin as a currency. Then many people thought about Bitcoin as a decentralized system to execute some contracts. And Bitcoin has some limited but features to manage contracts between people. But its successors and its peers, such as Ethereum, for example, they did a better job in this space and built full smart contract platforms. So we can think about Bitcoin as for now, as a payment system. That's the easiest way. And you pay just with Bitcoins. So why it appeared? Until the appearance of Bitcoin, people have problem that financial transactions are not always going fast because they are reviewed by financial institutions. And by some kind of default, there's nothing wrong with review, but sometimes it could be used to do censorship. So some, ecosystems, so to say, had problems with censorship, and people were trying to find a solution. How do they avoid censorship so they can kind of transact freely? We won't discuss the political aspect of these things, but the demand is clearly there. Like gray market, for example, is the simplest example. I'm not saying that the Bitcoin could be used only for gray market transactions, but yeah, it was used initially quite a lot. And every time people talk about Bitcoin, this topic is kind of raised. But the ultimate point is that Bitcoin is needed in order to allow censorship resistance. This is achieved by permissionless. Permissionless means that there is no need to ask anybody in order to do something, whether we sign a transaction, whether we accept a payment or do something else. We don't need to ask a permission. And it leads to censorship resistance. So this feature is the most crucial for Bitcoin and and for the cryptocurrency itself. So I will be talking about the, so to say, crypto asset classes next time. But for now, what we need to remember is that Bitcoin is a cryptocurrency, and cryptocurrency has the censorship resistant aspect. If a currency that you are looking doesn't have a censorship resistant, so you have somebody, a company, or the person who can control transactions to a certain extent, it won't be a cryptocurrency. It could be a digital currency, it could be some digital asset or whatever, but it won't be cryptocurrency. Then the principles behind Bitcoin. Again, the main principle is that all participants, they can participate in any role in Bitcoin, whether this is the data storage, auditor, transaction processing engine, or relay or something else. So we don't have particular roles in the system, so every person in the world can support Bitcoin in any way. It's a little bit more complicated than that. We'll touch this in next lectures, but the principle is like that. So if cryptocurrency will evolve, this principle will be used more and more extensively. So the architecture of Bitcoin, in layman terms, is that everyone can run a server that contains full history of all transactions up to date. And this server is identical to all other servers that people run. And these servers talk to each other and they reach consensus. So they synchronize regarding the state of the past transactions and the present transactions. So this is more like about the architecture of Bitcoin. And obviously, every person on the world can see all the transactions in Bitcoin that happened since its inception in 2009. Which is super strange for traditional financial system where you have a single organization that manages that and doesn't allow anyone to look the rest. So from one perspective, Bitcoin is censorship resistant. From another perspective, it's fully transparent, which is like super cool. Again, people didn't have anything like that in the past. And one example for financial people, one example of like importance of that for the other industries is that until Bitcoin, there was no to protect accounting system of any kind, whether a banking system or payment or some like stock market. People used the dedicated servers, specialized security administrators. They used firewalls, they used physical security, role-based controls, and so on and so forth. And look at Bitcoin, which doesn't have any particular server with access code. It doesn't have any security administrator or firewall, and it works. And you cannot come to one place and steal all the Bitcoins. And which means that the same level, even higher level of protection is achieved not by like physical force, but achieved by cryptography. So this is the principle about like how it's organized. We'll touch cryptography separately, but for now it's a science that studies how mathematics could be used to protect confidentiality, integrity, and accessibility of information. Okay, now we come to the life cycle of Bitcoin, and we see that the most important piece is a transaction. And transaction could be generated, could be signed, could be sent, relayed, verified, validated, and confirmed and stored in the like database. And then you have the concept of the block, which is the set of transactions that happen within a certain time. And again, you can form the block, you can validate the block, relay it, and you can connect blocks to each other. And connecting blocks looks like connecting, pages in a book. So you tie them together in a way that if you delete something, it will be clearly like seen something happened. So this is the concept. So to some extent, Bitcoin looks like a huge notary book, and every event is recorded in it, and you cannot modify the past. So this is the principle behind the storage of information of Bitcoin, so storage of transactions. They cannot be altered in the past and cannot be injected or modified or something like that. So it's it has the immutability component, which is super important again for audit and for trust to such a system. So it is organized in a way so you don't need to trust any person. Like ideally, it has some limitations, but the concept is like that. You only trust mathematics. So that's why Bitcoin could be called as programmable money, or it's the system based on rules, so people cannot change things. I will provide some example to show like how and why nobody can change something in Bitcoin when it operates in a malicious way. So when I explain all these things, people usually ask, okay, but what about like the creator, the anonymous guy? Like, can they change the rules? Can they steal my Bitcoins? Can they just come up and do something bad, print more Bitcoins. And they say like, look, just think about any card game that you like, poker, for example. Like I said, do you know who invented poker? They usually say like, no. Like, and I ask them, can the creator of the poker change the rules while you are playing, like all together? People say, no, doesn't seem feasible. Then I say like, okay, can the creator of the poker add some cards while you're playing? And obviously answer is no. Then I say, even if they play together with you, can they cheat on cards, on the rules? Yeah, I mean, they could play better, but definitely it's cheating. It's a completely irrelevant thing. So that's how I show that decentralization helps to create a secure system. So the creator is separated from the rules and from the tools. So a creator separated from cards and from the deck and from the rules of poker. So in that way, you have a lot of protection. And traditional centralized systems look like the online poker, where you cannot really validate what's going on. Because it's IT system and you don't know whether the random cards are really random or internet connection is not intercepted and so on and so forth. So, but playing in physical environment gives you a lot of assurance. And therefore, you can build a system, a digital system that has the same principles, but in a distributed way. This is the beauty of it. This is the, like, really, if you think, it's a groundbreaking concept, and it will be applied in many, many systems. So technical details, we will talk about them separately. We'll talk about mining, we will talk about proof of work, we'll talk about the transaction distribution and nodes and synchronization and many, many stuff on a different technical level. But for now, these principles are the most important. So now we touch the strong side. So the strong side is obviously that it's financial instrumental currency that can work without any limitations. There is no registration. So you can download the wallet and use it right away. You don't need to provide your email address or cookies or anything else. You just use it. Then the strong side is that there is a limited amount of Bitcoins in existence, and you have a proof that there won't be more. So inflation, which in a layman term is not applicable here, you have like mathematical formula that predicts how many Bitcoins will be at any moment of time. So it looks more like gold. That's why Bitcoin is often compared with a gold, like saying it's like a digital gold. Then you can use it anonymously to some extent, because anonymity and privacy are different terms. Here we say that it's hard to connect your address in Bitcoin and your identity, but since all the transactions are traceable and visible to everyone, it's not fully private. Although there are some private systems, private cryptocurrencies. We will touch them later, like Monero or Zcash, and we'll talk about their features. And it's resistant to censorship, so that's also important. Limitations. We have kind of limitations that stem from the design architecture of Bitcoin. Obviously, if all the people are involved in the transaction processing, it will be much slower than the centralized system. Although there are some improvements if you use additional layers like Lightning Network. Again, we'll be talking about this separately. You have the Bitcoin currency is non-fungible, which means that it's not like piece of gold, which means that every, so to say, coin is unique, And when I send it, effectively, you can trace how it was sent and to whom. And sometimes people say that Bitcoin is a triple accounting system. So it's you can see the where the money is coming from, to whom money is coming from, and like links between that, which is, again, it has some limitations. So now some Bitcoins are considered like dirty, and exchanges do not accept them. We need to touch also a question of price, which is super simple from one point. It's it depends on supply and demand, nothing else. But since the whole thing is anonymous, you can have a lot of manipulation, which is very annoying for people who used to like regulated approach and all the rules on the Wall Street, etc. But it has also some, yeah, so to say, fun to this. We'll be talking about how coins are created, why there are 21 million later. So just I'm mostly doing the most important principles now, and yeah. And then also some limitations and drawbacks is that you definitely have low transaction speed. Currently, it's approximately like 7 transactions per second, which is, yeah, compared to payment systems, it's super slow. But again, if you need censorship resistance, it doesn't really matter. You have sometimes high transaction fees, obviously, because many people are trying to use Bitcoin, and yeah, it creates a demand for that. And sometimes fees could go to $50 for the transactions, but sometimes it's just cents for any size of the transaction. So you also have the quite long transaction confirmation time, which could be up to an hour or even more, depending on how you define your risks. For small transactions, risks are not high, that people usually wait, 10 minutes or so, something like that. But yeah, 10 minutes, it's not 3 seconds or 2. These are features that can be improved in other cryptocurrencies that will come after Bitcoin. We will talk a little bit about trust, because it's also a simple some drawback to a certain extent. There is nobody who can blame that you lost your Bitcoins if you lost your key to this. So the user is the owner of everything. The user manages their possessions themselves through a concept of a private key. We will talk about this separately. And if user loses the key, then the Bitcoins are lost. Many techniques are used to protect user from that, but there is no perfect solution. Like security is always comes for free. So these are the most important features. Regarding the competitors, I mean, from the financial industry, there is little Bitcoin you can compete with, because it has like different architecture and principles. From the systems that appeared after Bitcoin, there are other cryptocurrencies that have some features, some better but more complex. There are systems that are digital asset systems but not cryptocurrencies, like Ripple, for example. And there are other things that are used as a currency, so to say. But Bitcoin, I would say, stays a little bit aside. So if you need a censorship resistant system, for now, that's it. So there is no like really a big choice. Okay. We have the question about Polkadot. We will be doing a lecture about Polkadot, so otherwise it will be too long and not relevant to this lecture. The last thing I want to comment is that the system, Bitcoin, is quite hard to to manage worldwide, because we need to talk about upgrades. And upgrades of a decentralized system are super hard. Just think about how long it took, and still haven't done fully, to switch from IP version 4 to IP protocol version 6. Because when you have many participants who need to reach an agreement and invest money in this update, it becomes super complex. So the Bitcoin is developing quite slowly. If we compare it to Facebook, for example, but it provides with higher resilience. So there are only a few dozens of people who are working actively on Bitcoin, like every day. But that's anyway, a big project. Other other currencies and projects often have much smaller teams. Okay. For the tendencies, sorry. For the tendencies, we had a segregated witness acceptance. It was in 2017. We had Lightning Network launch, 2018. We'll talk about separately. And very recently, we had the launch of Snort Signatures Plus Taproot. This is the nearest events. Just one second. Yeah, sorry. This is the nearest events. Bitcoin may become more private in some future, but it involves a lot of cryptographic complexity. What it means is that Bitcoin looks like a stone. It is very simple. From a cryptographic perspective, it uses very simple techniques. But anyway, people can evaluate it. They can check the code base, they can check how it goes, etc. More complex systems that involve very hard, deep cryptography, can be evaluated only by a few people in the world. So we had events like with bugs in Zcash, and 3 or 4 people in the world can actually check what's going on in there and find the bug or fix the bug. And this, so there is some, let's say, relation between the functionality and development of the technology and complexity and understanding of the general crowd about it. So the more complex is the technology, the less reliable it becomes and more risky is to use it. So Bitcoin has found, at least for now, some niche where it can be used. I want to address one more concern regarding the future development. It's like quantum computers. Some people say, it has a reason, that as soon as we have quantum computers, Bitcoin will be broken and everybody will lose their money. It's not fully true. Like Bitcoin has some anti-quantum techniques, and all the financial industry will be kind of under attack. So how it will be solved? A new cryptography already there. It will be just integrated in these solutions. So nothing super special. It's like when the thief has the better tool to break your door, you just install a better door. So so Bitcoin is a live system. Okay, I think it will be enough for one time. So the basic principles. If you ask your questions on YouTube, I will answer them there. And see you on the next lectures.